In this video, we are going to discuss about change of state. We have seen water. So the molecular formula of water is H2O. That means 2 hydrogen and 1 oxygen combine to form this water molecule. This is called molecule. This group of molecules can exist in solid, liquid and gas state. Solid, liquid and gaseous state. Because when in solid state we call it ice, in liquid state we call it water, in gaseous state we call it steam. But the same H2O molecule exists as a solid, same group of H2O molecules exist as a solid, they exist as a liquid and they exist as a gas. What happens? These H2O molecules, so each one is a H2O molecule. So each H2O molecule is just held together by a force called intermolecular force. Because these are all molecules, the force among them is an intermolecular force. These intermolecular forces just keep them tightly together, so they are making a solid. When you add heat, heat means energy. When you give energy, what happens? These start moving faster. Heat is the energy of random motion. When you add heat, they vigorously vibrate. They move here and there. When they start vigorously vibrating, they move far apart from each molecule. Then the attraction force weakens, because the more the distance between the molecules, the less will be the attraction force. Then at one point, when you add sufficient heat, that becomes liquid. Even when it becomes liquid, each one is still H2O only. Each one molecule is still H2O only, but the force among them are weak. The forces among them are weak. They are just moving here and there, but still there exists a small force between them. Because of that, they are not escaping from each other. They are still forming a definite shape in a container. So again, when you add heat, again you are adding energy. When you add energy, even the weaker forces that exist among the molecules, it gets even lesser. Then still it will still be H2O only. Just look at this thing very clearly. The hydrogen separately, oxygen separately cannot go. So they are still separately like this. They are just moving here and there like that, because now they do not have a definite shape. You can't see that, you can only feel that. Now it has turned into a gaseous state. So when you add heat energy, it becomes liquid, solid becomes liquid. When you add heat energy, liquid becomes gases. So a liquid is nothing but solid plus heat energy, right? So the energy is inside the liquid, right? We call it internal energy. Internal energy of liquid is greater than internal energy of solids, and internal energy of gases is even greater than internal energy of liquids and solid together. So but here, as you keep on adding heat, the temperature here increases. The temperature at which there is a particular temperature at which solid suddenly becomes liquid. So the temperature at solid becomes liquid is called melting point. The temperature at liquid becomes gas is called boiling point. If you cool down, so let me just write it separately here. So this is a solid, this is a liquid, and this is a gas. So what happens here? So the temperature at solid becomes liquid is called melting point. But when you cool down, liquid becomes solid. So in the cooling stage, that is called freezing point. See, these two are almost the same. Like when you heat up, solid becomes liquid. So while heating up, when you heat up, we call melting point. When you cool down, you call freezing point. But the temperature, the exact temperature at liquid turns gas is called boiling point. Boiling point. The temperature at liquid turns gas is boiling point. This boiling point is while heating up. While heat up, you call boiling point. But when you cool down, this becomes, gas becomes liquid when you cool down. That is called fusion point. Fusion point. Fusion point and boiling point are the same, but that this is when heating up. This fusion point is when cooling down. But sometimes, so I mean, this melting point, let us look at this melting point. It's very important. If melting point is more, that means we need more heat energy to convert solid into liquid. Then that means the intermolecular forces that are holding the solid particles are really very strong. If melting point is more, then the solid, I mean, the intermolecular forces are very strong. So it is an indirect cue. So the greater the melting point, the greater is the intermolecular force that exists among the solid particles. So this way, solid turns liquid, liquid turns gases, and the energy relation. Sometimes solid directly becomes gas upon heating up. The temperature at solid turns gas directly is called a sublimation point, and the process is called sublimation. Think about a camphor. When the camphor burns, it directly turns into a gas unless it is more adulterated. So a camphor directly turns into a gas. So this process is called sublimation. So melting point, boiling point, and this most important thing. So boiling is different, but there is also another thing. So evaporation. So the process of liquid turns gas at a particular temperature is what is called boiling. But the other thing we are talking about is evaporation. What is evaporation? Suppose you have a glass of water and you're looking at it for half an hour or 1 hour. You don't seem to be like the water level don't seem to be going down. But if you just pour this half cup of water on a large surface, and after a while the water suddenly disappears, or the water slowly disappears. So why the water kept in a container is still there, but water just poured on a floor disappears after a while. So because of one thing. See, when you boil it, the atoms and molecules, or the molecules that make up this liquid, gain sufficient energy, and then they escape and they become part of the atmosphere. So that means they are becoming gas. But at the surface here, molecules inside, they do not have enough energy to come out. Okay, but even when you don't heat up, at the surface there are a few molecules. These molecules sometimes they escape into the gas without even getting, because here constantly the air molecules are getting bombarded. So these molecules at the surface are getting bombarded by the gas molecules. So accidentally 1 or 2 molecules, they receive energy from this and then they escape. And this is possible only at the surface, only at the surface. So in any liquid surface, the molecules at the surface, liquid molecules at the surface, they tend to escape into the air. And that phenomenon is called evaporation. This can happen at any temperature. And only at the surface. So evaporation is a phenomena. And evaporation is a surface phenomena. Surface phenomena means it happens only at the surface and at any temperature. As long as that is a liquid. So evaporation. So that is why when you just pour the glass of water onto the surface area increases. So every molecule at the surface slowly escapes into the air, and after a while, because there is a large surface, the number of molecules escaping into the air is also more, hence they disappear very quickly. But here on a glass of water, it's a small tumbler of water, the surface is very small, and hence the atoms or molecule that escapes into the air, its number is very less, so it takes longer time, but it does take place. Suppose you take 1/2 tumbler of water. Whenever you go for, say, your summer vacation or something, you keep 1/2 tumbler of water at home. After 1 week or 10 days, when you come back and see, you would find the liquid level or the water level decreased in that. So this is about the change of state. Whether change of state can be affected by anything? That is our next question. Can change of state be affected by anything? Yes, change of state can be affected by anything. That is with the help of pressure. Pressure. Suppose let's talk about this. There is a bucket or a container in which water is there, and you are just boiling it. But when these molecules, water molecules, when they try to escape into the air or something, if you put pressure here, when you put pressure here, you are forcing the atoms to stay. So these atoms need even more energy to escape into the air, because consistently there is a more force or the pressure which is being exerted from outside. When more pressure exerted from the outside, for these molecules it gets difficult to escape. Previously, suppose if you are giving some heat energy H to these molecules, and this liquid boils and then they escape. But when you exert pressure from outside, they cannot escape with the amount of heat you are giving. So you need 2 times the heat sometimes so that they escape. Even beyond the pressure, some molecules escape in that case. So for that, what you need to do? You need to double the amount of energy or triple the amount of energy based on the kind of pressure. If you apply more pressure, you need to give more energy for them to escape. So when you give more heat energy, the temperature increases. So when pressure increases, the temperature at which these molecules escape increases, and that is called boiling point. When pressure increases, boiling point also increases. Boiling point increases. One simple example: if there is a container, the container is open and the atmospheric air is exerting pressure into it. So this is water. When you heat water, exactly at 100 degrees Celsius at normal atmospheric pressure, water turns into steam. But in a pressure cooker, when you put a lid, what happens? When the water boils, some steam will be formed here, and the steam cannot escape. When more and more steam gets here, there is a pressure that is being built up here, and because of the high pressure here, for the remaining water to boil, it becomes very difficult. So water here boils at 100 degrees Celsius. At high pressure, very high pressure, let's say double the pressure, water boils at 125 degrees Celsius. This is nothing but pressure cooker. Pressure cooker, water boils at not at 100 degrees Celsius, but more than 100 degrees Celsius. This is about the pressure, the effect of pressure on the boiling point. The boiling point increases. What about the melting point? The other point is melting point. So you would have seen, suppose if there is a large ice floor, they play ice hockey or something. When you look at their shoes will have sharp edges at the bottom. So the shoes or the thing have sharp edges at the bottom. These, when a person stands on that shoe, what happens? His entire weight acts on a very small area, so the pressure at this point increases. When pressure increases, usually this ice floor is kept at, let us say, one example, this ice floor is kept at minus 10 degrees Celsius, because the ice melts at only 0 degrees Celsius. But when the person is standing, his entire weight is on a small area. At these points only the pressure increases. When the pressure increases, even at minus 10 degrees Celsius itself, the ice melts. So when you look from the side, this is the ice floor and the person is standing here. At this point where he exerts pressure, the ice melts and there is a layer of water between his shoes and the ice floor. So because of the high pressure exerted, here the ice, even at minus 10 degrees Celsius or minus 8 degrees Celsius or minus 4 degrees Celsius itself, it melts, and hence this water acts as a lubricant so that they are able to move or glide faster on the ice floor. So what do we come to understand from this? The melting point decreases, because not at 0 degrees Celsius, even at negative temperatures itself, ice melts. So the melting point decreases when the pressure increases. So we have just discussed today the change of state and the effect of pressure on the boiling point and melting point. So the pressure increases, boiling point decreases, melting point. So remember that. So pressure increases, boiling point decreases, melting point.